Okay, so now we're going to start on 12.3 and 12.5. We're going to learn them together. I'm going to introduce two of the triangle congruency theorems to you. So the first one we're going to talk about is side angle side, which is written or abbreviated SAS, as you can see right here. But you need to understand what it means, okay? So the side angle side congruency theorem states that if two sides and the included angle, that's why the A is between the two sides. Look at your diagram down here. You have two sides and it's the angle where they connect. Okay, so that's very important that you understand that. So it's the included angle of one triangle are congruent to the two sides and the included angle of the second triangle. Then the two triangles are congruent. So you can read that information right here to understand it a little bit better, but know that it is side angle side. And that's where those initials come from. Okay, so we're going to do a couple proofs. Just knowing how to do this is helpful. So make sure that you look at your diagram and read your givens. So BC is congruent to DA. So that symbol there means congruent. And then it says BC is parallel to AD. And there's our symbols for parallel. So as soon as we see that, we need to think of things a little bit differently. So I'm going to remind myself that that means that this right here is a transversal cutting through two parallel lines, because that will help me when I get to my proving things. Okay, so all I have right now is that those two sides are equal. So I look at these two statements here. Here's my given. Okay, whoops, I forgot that I already have them there. And these are both givens. Okay, now look at this one, BCA. So find that angle BCA. Okay, and DAC. Start with the D, go to the A and C, and mark your angle. So look at those two angles. Remember I told you think of these as two parallel lines cut by the yellow transversal, and those are alternate interior angles. So the alternate interior angle theorem is used to prove that those are congruent. Okay, then we have AC equals CA. That's this middle line. And yeah, it looks different, but it's actually just naming it backwards and forwards. So that is the reflexive property. And now notice we have, and you don't need to write these letters out here. I'll show you where I want you to write them. I just put them there for your information. So now we have our triangle. You still have to worry about corresponding parts, and we use the side angle side congruence theorem. Then over here next to it, you're going to put the numbers where you proved each one. So the first side was proved with number 1. My angle was proved with number 3, and my second side was proved with number 4. I will warn you that they don't always come in the same order or in order, but that's how you do it. Okay? So these are just here for your convenience so that you remember that you always want to have all your parts showing. Okay? All right. So now we're going to do another proof. So look at this one. We've been given BD is perpendicular to AC. So there's our 90-degree angle there. That tells us that this is also a 90-degree angle because these are a linear pair. Okay, they form a line. Then AD is congruent to CD. So look at those. So the first thing we're going to do is put our givens. So number 1 is BD is perpendicular. What's going on with my pen? There we go. BD is perpendicular to AC, and AD is congruent to CD. And those are given. And you can put them on separate lines or together, your choice. Okay, so we're trying to prove that ABD is congruent to CBD. Okay, so we've got to prove some more stuff. So we have a side and an angle. So think about it. We've got an angle. Okay, so and a side. We forgot to put the so we've got to show that those angles are equal because this by itself doesn't tell us that those are equal. So we're going to say angle BDA and angle BDC are right angles. Whoops, are right angles. And I'm going to say the definition of perpendicular. Now that I've got that, I can go to my next step, which says that those angles are equal to each other. or congruent in this case, BCD, and that would be right angle congruence theorem, which states that all right angles are congruent. Okay, so that's that. And then, so now I've got a side, and I need one more side. So I look around and I go, well, I can't prove these two, but I've got this one right here. So I'm going to say BD is congruent to BD by the reflexive property. It equals itself. Okay? And you could say reflexive property of congruency, or just put reflexive property. That's okay. And finally, I'm going to say triangle ABD is congruent to triangle CBD. And how is it congruent? By side, angle, side. Okay, so side, angle, side. My first side was proved right here. Let's put the colors in there so you can see that. My first side was proved there, so number 1. My first angle was proved in number 3. And my last side was proved in number 4. And so that's how you would finish your proof. Alrighty. Okay, in this proof you want to be very careful that you understand all the parts that they're giving you. So the first thing that they're going to say is Jn is equal to Mn. So that is this piece here, and it is congruent to this piece here. And then Nk is congruent to Nl. And you can see that that's these bottom parts here. So finally, you want to look at what am I trying to prove. So look at the triangles that are listed. We've got JNK. That's this triangle right here. And they want you to prove that JNK is congruent to MNL. And that is this triangle here. So it's really important that before you get started, that you ask yourself, what is it that I'm trying to prove? Okay? So I'm going to start with my givens. So Jn is congruent to Mn, and Nk is congruent to Nl. Those are my givens. Okay? You can put them separate or together, your choice. Okay, then number 2, what else can I prove in here? Okay, there is nothing to show me that angle J is equal to anything, or angle M, or angle JKN, or MLN, and I can't prove that these sides over here are congruent, so what's left? So remember, you always have your toolbox, so look for everything, and right here I can see that I have vertical angles. I have 2 lines intersecting, so I can say angle JNK. Now this is what you're going to notice. I'm going to do this a little different, and angle MNL are vertical angles. Okay, I'm not going to say that they're congruent yet. I need to say that they're vertical angles. And that's by the definition of vertical angles. Okay, then I'm going to go to number 3, and I'm going to say that they're congruent. Because now that I've shown that they are vertical angles, I can say that they are congruent by the vertical angle congruency theorem. Okay, so now if you look at this, look at your triangles, I've got a side, an angle, and a side. So I'm ready to go ahead and prove this. Triangle JNK is congruent to triangle MNL by the side angle side congruence theorem. And then I'm going to put my numbers. So my first side is here. My angle is number 3. And then I go back to number 1 again for my second side. So that's how I would write it, so that I knew where to find those pieces. This is a great way to remember that you have the three pieces to account for. I've had students that will solve the SA and forget about the third side, but when they started doing this, they didn't forget that third side. So remember how to do that. Okay, so we're going to use side angle side here and some properties of shapes. So in this diagram, QS and RP pass through the center of the circle. So they are diameters. Okay, and what can you conclude about these two triangles? Well, the first thing I want to say is that MS is congruent to MP, okay, and also congruent to MR, and also congruent to MQ. And that's because all points on a circle are the same distance from the center. So these are points on the circle, and they're the same distance. Those are the radius, right? Those are all radii, so they are all congruent, okay? So that proved that. Now I'm going to look at this, and I'm going to say, okay, we've got this triangle. They want MRS. So do we have any angles that we can prove? Again, I'm going to look at those vertical angles, and I'm going to say that triangle MRS is congruent to triangle MPQ by side angle side. Okay? So that is a really good little proof. And this is how we do proofs without really putting them in formal order. And that's pretty much all you'd be asked to do in a regular IM1 class. Okay, these are more problems from your journal. So look at this one. We have use the given information to name two triangles that are congruent. So they gave us these two angles are congruent. Make sure you understand that those are not vertical angles because they have their vertical angles are made from two lines intersecting, and there are three lines here. So make sure that you understand that, but they gave you that these two are congruent. So P is the center of the circle. That means PE is congruent to PF. All the radii are congruent, so PH and PG. So now I've got this side and this side and this side and this side are all congruent. So I can prove that triangle HPG is congruent to triangle EPF. And that is by side angle side. Okay, so we have this regular hexagon, and they want to know if there's any triangles that we can prove congruent here. So the first thing I know is that all the sides of a regular polygon are equal. So AF is congruent to ED. Okay, and then they want you to understand that this line, which is cuts it into two equal trapezoids, is equal to EB. So we're going to say FC is congruent to EB because it also cuts it in half. Okay, so we've got those two sides. Now, here's where it gets a little bit tricky. We know that the interior angles of a regular polygon are all congruent. Okay, and FC bisects angle AFE, and EB, or BE, bisects angle FED. So now these are bisected, okay, which means the interior angles are equal, and when you bisect them, that these are equal, okay? So actually it's this one that I want to be equal. So that means that angle BED is congruent to angle CFA. Okay, so now we've got those two triangles, those two angles congruent. So we've got side, angle, side again. And so triangle ACF is congruent to triangle DEB. Initials could be different if you want, by side, angle, side. Hopefully you understand side, angle, side now. Make sure you remember that it's the side, the angle in between. So side, angle, side. Okay, so the next congruence theorem we're going to look at is side, 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 which is really simple. And we're going to look at the hypotenuse leg congruence theorem, which is only used with right triangles. Okay, so the side, side, side congruence theorem says that if three sides of one triangle are congruent to the three sides of the second triangle, then the triangles are congruent. So let's look and see if we can prove that these are congruent. So I look at this one, I've got it, they want you to decide, is this true? Okay, so you're saying true or false. So we have triangle DF, or angle DF, that's 2, and HJ, that's 2, and then FG is 3, and JK is this, and so the answer is yes by side, yes by side, side, side. Okay, so look over here. We have this side is congruent to itself by reflexive property. This side is equal to this side, but these sides are not equal, so the answer is no, or false. Okay? Over here we have this side is equal to this side. Okay? We have this side is equal to this side, and we have the last one. So yes, that is true by side, side, side. Let's look at some more. So decide whether the congruent statement is true. So for this one, these are isosceles triangles. We can see that like this. Okay, and then these two, the bottoms, the bases are both equal. So yes. Now here's the kicker. We know that because these angles are congruent, these base angles are congruent, which makes these true. So now I could do side angle side, or I could do side, side, side. Okay, so for this one, that's true. I could also, we're going to learn about angle, side, angle, if I used these right here. So that's another way. So just remember how it is. So this is side, angle, side. So we've got a side with an angle in between. Okay, so let's look at this one. We've got GH is congruent to JK. We've got GK is congruent to HJ. Can we prove any of these angles are congruent? No, because it doesn't say that the sides are parallel, but we can say that HK equals itself by the reflexive property, and therefore it's true by side, side, side. Okay, so this is true. All right, again down here, pretty easy. You see all three sides marked. Look them over, make sure. So the answer is yes or true by side, side, side. Okay, now down here, be careful with this one because notice that the sides are flipped. So we have SR is to RP. So SR is to RP. And then the next one is ST, that's this side, is to PQ. So that would be this side. So that works. Okay, so these would be congruent by side, side, side. Okay, we also could say these vertical angles are congruent, and we could prove side, angle, side. So remember, there's lots of ways to do these. Make sure that you're looking for all the possibilities. Okay, so in general, this one, side, 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 is not a valid method for proving that triangles are congruent. In the triangles below, two pairs of sides and a pair of angles not included between them are congruent, but the triangles are not congruent. So when we were doing this with compasses, what we did was we took this side that was congruent, and I want to draw it in a different color. So this one is congruent. And what we did was we said this side is going to stay the same and this angle is going to stay the same. And all I'm going to do is I'm going to take my compass and I'm going to make an arc. And I'm going to extend that red line. Okay, so I'm just going to draw that red line out here. By using this measurement, by taking this compass and sliding an arc around, I am making sure that that side is going to stay the same length. Okay, so this is equal to this. But you can see right away, especially when you look at this angle here, this angle is completely different. So look at angle C and angle F. They are different. Okay, they are not the same measure. So that way, that proves that side-side angle, and if you reverse it, you can see it's a bad word. So in math, we don't use bad words, so this is not a valid statement. However, I'm going to have to erase. However, when it is a right angle, we can use it. So the hypotenuse leg congruence theorem is angle side, side. But we can't say it angle side, side because that's wrong. So we call it hypotenuse leg. So here's your hypotenuse, here's your leg. And it could be the other one also, could be this leg. So it could be a hypotenuse leg, and we don't even worry about the angle because the angle is given because this is a right triangle theorem. Okay, so that's the key to this one. So stop and read this if you want to get more clarification, but just understand what you're looking at. Okay, so let's use this in a proof. So we've done all of our givens. I'm going to go ahead and mark the drawing. So we've got WY, that's this one, is congruent to XZ, that's this one, that's the whole thing. Then they said that WZ is perpendicular to ZY, and XY is perpendicular here. Okay, so we've got three different things. So if you separate these, it might be easier to see. I often suggest this to students because it helps them see it a little bit more clearly. So we have W, Y, Z, and we have X, Y, Z. Okay? So now what I want you to notice is that you've got WY is congruent to XZ. You've got these two right angles. What is left that we could say is congruent? So first we put the givens down. Then we say that angle Z and angle Y are right angles by the definition. Whoops. Oh, so they redrew them for you. And by the definition of perpendicular lines. And so that tells you that these are right triangles, definition of a right triangle. And then we're going to say ZY is equal to itself. So we got all these different drawings here. ZY is equal to itself, and that would be reflexive property. And now let's just erase all this stuff. So now you can see that these are now equal by hypotenuse leg. Remember, you cannot call it SSA or ASS. It has to be the hypotenuse leg based on the fact that it is a right triangle theorem. Okay? So that's how you use that. So they want to know, are these congruent? So notice that these are equal. So I'm going to say yes, these are equal. And this is equal to itself. So yes, by side, side, side. Okay? Over here, now this one's a little bit more difficult, but you'll learn how to do these later. So if you want to separate them, it might be a little bit easier, but you have to think about what you're writing, okay? So we've got A, B, C, and I'm going to put that F right here, okay? And this is 3. And then over here, I'm going to put C here, and I'm going to put 3. This is D, E, B. So I can see that these are both 6, so that makes them congruent. These are congruent to each other. And this angle is 75, which means it's congruent to this angle of 75. Okay, so we're looking at these drawings. But if I look at this side is 3 plus FC, and this side is, that's an F right there, sorry. This side is 3 plus FC. Now in a regular proof we'd have to prove all of this, but I'm just showing you that these two sides are congruent, the whole side. So now we have that the triangles are congruent by side, angle, side. Remember, you have to get the whole side is congruent, okay, because that's the whole part of the triangle. So we proved it right here.